Assembling the Building Blocks of Smart Manufacturing. This is the second in a series that we have started around the partnership between Klika, Lenovo, and Amazon. And in section 2, we're going to get a little bit more into details around the building blocks around smart manufacturing. So as I said, this is the second in a session in a series of different events that we have done. Here are our panelists. And so without any further ado, Ryan, why don't you take it off first?
Hi, thanks everyone for joining today. My name's Ryan Vanderwerf, and I'm a Partner Solutions Architect with Amazon Web Services. And what I do is, on a daily basis, I work with partners like Lenovo and come up with solutions, going to market with partners, growing people's businesses. So, and I'm a technical component of that part of the relationship. So, yeah, I'm glad to be here. I'll hand it over to Mark.
Yeah, thanks, Ryan. I'm Mark Chronic from Lenovo. I've been here for about 13 years, and I lead our business team that's defining this new Smart Edge product category.
Excellent. Konstantin?
Thank you. Hello, my name is Konstantin Misharyakov, and I am Solution Architect at Klika. What we do at Klika is developing end-to-end IoT solutions from embedded part to the edge solutions to the cloud. And my area of interests and responsibilities are embedded engineering, cloud, and machine learning. And this goes very well with the current project, which we are going to introduce. Thank you.
And my name is Steve Brummer. As I said, I'm a co-founder and a partner at a company called BH IoT Group. And we are a world-renowned company that helps companies bring their products and services onto the market around IoT. So for us, it's all about making money, the monetization, commercialization strategies, and the execution programs that are necessary to allow companies to bring those products and services to market in a successful manner. So here's our agenda today. We're going to talk about steps for implementing off-the-shelf solutions. What we're looking for from a plug-and-play standpoint is that architecture and all the pieces of it that are necessary to be able to provide the data off of the manufacturing floor and process that information, whether it's coming from an edge, whether it's for automated or rapid response. So if you start to look at off-the-shelf solutions and the ability to take a simple way of being able to show and bring that data to you, that's what we're going to show you today with the partnership between Klika, Amazon, AWS on the cloud, as well as Lenovo from a physical gateway standpoint. We're also going to show you a demonstration of a development kit for processing and monitoring that data from equipment level sensors. And Mark is going to introduce you to the Nano IoT, which is an absolutely great product, new product in this space, and the impact that this product will have with faster equipment level decision making. And then we're going to also talk, and Ryan's going to talk a little bit about extending AWS's IoT Greengrass to the edge for seamless and more efficient device to cloud data management. Mark, you are up from Lenovo. It's all yours, and let's go.
Thanks, Steve. Yeah, so I think it's important to think about as Lenovo re-enter this market. You know, for this discussion today, we're going to specifically discuss manufacturing. And really, it's around addressing the needs and problems of that market. How are we addressing with our product portfolio that marketplace? And you see these use cases here, right? Some of these are, how are these, you know, incumbent type of implementations evolving with better compute over time? Things like PPE, typical monitoring of supplies and utilities, those implementations have been ongoing. The real question is, how does that evolve to the next generation? And then, of course, there's other use cases like COVID-19 access monitoring that we're trying to address. You know, edge computing is a broad topic. The way Lenovo looks at this space across our business, from everything from edge compute, PC devices through data center, is the fact that gateway devices need more performance. The types of applications and use cases in market, what customers and integrators are looking at is to drive more data, but also to be able to drive that data with real-time business decisions coming real-time. And of course, the question is really, how do you take all that and implement it effectively for your business to have the right return on investment? So, I think the question is, how's Lenovo addressing this space? Holistically, it's around us delivering to a market more compute power. And this is something that we do very well across of our data center, desktop, and PC business. And now we're going to go deliver this into the edge space, but not with general horizontal products. This is really with purpose-built offerings. And we'll talk about with some of the examples around rugged, extended temperature, and such, that really be able to connect into both those legacy spaces as well as new spaces. When we're working with partners like Klika and AWS, it's not only us delivering great hardware, but how are we deploying that seamlessly with their tool set in global scale, right? The end of science projects to real deployments is really what our strategy is. So I know Steve was very complimentary around the Nano IoT. So this particular offering is our Intel-based M90N Nano IoT, where we have variations all the way from Celeron through i5 vPro. We have a long life IoT G SKU. And we're deploying this across the globe right now into 180 countries. It's really a product isn't not like this in the space, right? So you're getting a half a liter design offering, which is essentially half of the size of a small form factor desktop, with a lot of capabilities, performance. That device actually can also connect to a thing we call the I/O box, which actually brings in power over Ethernet, DC power, really shows our flexibility and capabilities into entering any type of space from retail to manufacturing. I'd like to point out the fact that we do have an AMD version of this product as well, the M75N. And it's really around us bringing a lot of rich capabilities based off of customer and integrator needs at price points that are hard to beat in the marketplace. But again, Lenovo, we're not a one-trick pony. Not only do we have the Nano family of products, but we go up the stack, right? So not only do we have a broad set of compute, but specifically we have our APC 300 product, which is available today, that gives you up to 32 gigs of memory, an IP50 rating, a really rich integrated edge PC. That's a step up. And then as you go into the data center world, a product here with a Xeon D processor that holds up, that's an amazing engineering feat that can hold up with T4 graphics from NVIDIA. So just shows like from low to high, Lenovo code can really expand across the space. And I think it's, again, to the point of why why people like to partner with us, why we're obviously excited to partner with Klika and AWS. Our ability to innovate and bring great products to market at a hardware level, we know we can't do this ourselves. But the fact that we can support partners as we go to market with a full product catalog, security baked into our manufacturing line all the way into the product. And then, of course, being able to service these products across the globe as a tier 1 OEM is something we pride ourselves on, and something that's going to be a baseline to our success in the future. The real value proposition that we're bringing to market is that combination of better compute, better quality product that's going to be able to run that long life cycle at price points that are not like some of the incumbent suppliers. The combination of great engineered products that hit the spec that we can ship globally, as well as not requiring high MOQs like a lot of the incumbent products. We can be very transactional when we need to be, but we also have a really strong OEM business where we can do customization and really meet any need in the market, both hardware or imaging wise. So maybe we just pass over to Konstantin.
Okay, thank you. And let me speak about the solution we have created with Lenovo IoT Gateway and AWS services. Okay, it's natural that when one wants to add remote monitoring, anomaly detection, predictive capabilities to their manufacturing process, people don't want to invest a large amount of money to replace all the equipment, to have it connected to the cloud. It's more logical to enhance the current one with external and, if possible, and desirable internal sensors and processing modules such as industrial gateways. Some equipment can also be controlled externally. So with this gateway, not only the remote monitoring can be added, but also remote control. Naturally, this will require that every element is as secure as possible, and this is the area in which Lenovo and AWS excel at. To produce the demonstration solution, we have decided to follow the same path. We didn't have the equipment at our hands that we could enhance, so we decided to build it from scratch. As the base, we chose the amazing wire bending machine project designed by Irgi Pros. Excuse me if I pronounce the name incorrectly. This machine is largely 3D printed, but needs some additional components. You can see the main components of the machine are two stepper motors, straighteners, a wire guide, and a bender here. So these are a miniature model of manufacturing equipment that we decided to enhance to provide remote monitoring and control. So let's move on to the hardware architecture. This is our hardware architecture. The first thing we needed is a gateway that can control the machine and collect the data from sensors we were to install. Lenovo Think M90 IoT Gateway is a great choice for the task, as it is an industrial-grade gateway that can run Linux and AWS IoT Greengrass, which greatly simplifies the integration with AWS services and management of the gateway software. But you already know about it from Mark, so let's move to the sensors we have installed on this machine. So many possible sensors can be suitable for different types of equipment. We have decided that our machine will need only 3 of them. The first one is the temperature sensor. It plays an important role in most of the predictive maintenance solutions, as the temperature anomalies usually indicate mechanical or electrical problems which can lead to failures. We have decided to employ the Maxim DS18B20 sensors, which are inexpensive and provide reasonable accuracy for our task. We have added one Silicon Labs SI7021A20, which is more expensive, but also gives information on humidity, allowing us to monitor the environment to prevent equipment damage caused by moisture. Another useful type of sensors for anomaly detection is accelerometers. They can be easily installed on almost any component and are very useful for vibrations detection. Some vibrations are natural in almost any manufacturing process, but excessive vibrations indicate mechanical issues and can lead to subpar quality of the end product. We used the LIS3DH sensors manufactured by ST Microelectronics. Notice that in the setup with several such sensors, an I2C multiplexer could be needed. And at last, we also added current sensors. They are more difficult to install, but they can provide priceless insights for such parts, for example, as step motors. We have selected the Texas Instruments INA169 sensor for this purpose, which has an analog output and thus needs an ADC to transmit readings in digital form. As you can see, different sensors use a wide variety of interfaces to communicate. In our case, we had I2C, one wire, and additionally, we have employed ADC to read analog data. It is best to use a real-time system to work with such interfaces, so we have developed a small helper board. It handles the data from the sensors, wraps it into the MQTT protocol, and sends it to the gateway. Greengrass installed on the gateway processes the data and sends it to the cloud. For the remote control, we needed to operate 2-step motors. Typically, this is done through the specialized drivers. We used Allegra's A4988 one, which is controlled using current pulses. There are strict timing requirements of these pulses, so a hard real-time controller is needed. The board that controls the steppers was initially based on the Arduino platform, that we have replaced with a more powerful RISC-V based board. We wrote the firmware for this board that accepts the G code via UART over USB. The cloud can control the machine by sending the G code for a wire form in MQTT messages. The board sends back the progress and status of the bending to provide visual feedback. So here is our cloud architecture that we used in our project. There are main blocks that support remote monitoring, remote control, and anomaly detection in the cloud. We have built the cloud part on AWS infrastructure using such services as AWS IoT Core as an MQT broker, Amazon Kinesis service family for streaming data ingest and processing, Amazon Elasticsearch for data storage and dashboards creation in Kibana, and Amazon SageMaker for machine learning related tasks. The dashboards are integrated with a single page application written using the AWS Amplify framework. Here you can see the dashboard. It shows us the data from accelerometer, temperature data, and the data from current sensor. Also, we can send a G-code to the device and see the status. We have preloaded the spring figure G-code, which bends a spring, and also we can use any G-code to bend more sophisticated details. So let's see how it's work in the real life. You see that we have 1G on the Z accelerometer readings and almost nothing on other ones. So you see that the wire was feeding using the feed wheel and bent using the bending wheel here. And also you can see that we have readings on our accelerometers. We can use it to power anomaly detection on the gateway, for example. If we send the model there, it is powerful enough to detect any anomalies and provide predictive maintenance functionality using Greengrass and SageMaker Neo optimized models. So there are two temperature sensors from Maxim, one temperature and humidity sensor. There's also two accelerometers from ST Micro and two current sensors installed for each motor, step motor. So that's about it.
So audience, this is a perfect example of how Klika, Lenovo, and AWS can work together, processing and monitoring that data from equipment level sensors. It's a great demo. It involves all three organizations, and it shows you exactly what and how easy it is to be able to take those components and be able to get and extract that data. Ryan's going to talk a little bit about extending AWS's IoT Greengrass to the edge for seamless and more efficient device to cloud data management.
My name is Ryan Vanderwerf. We talked to you a little bit about the things that we did on the AWS side to make all of this happen. All right, so I'll talk a little bit about what we have as sort of our IoT virtuous cycle, right? So we have different kinds of services that come together in our IoT system. We've got analytics services, we've got device software for the devices like Greengrass and FreeRTOS, and then we've also got IoT Core, which is you saw demonstrating today, which is the heart of sending all these MQTT messages that go back to the cloud, and you can take actions on them. And then from there, the analytics services can kick in and do other tasks in the cloud that are off of the edge. So this kind of is a complete cycle. We call the IoT virtuous cycle, where you can keep doing this over and over again with all your devices and kind of have this harmonious, fully working application system. All right, so IoT Greengrass, we saw that used today in the wire bending demo, and really what that is it extends AWS services onto your devices, and you can act locally, and they can generate, take advantage of the cloud. So things like Lambdas that are running serverless applications are automatically pushed via Greengrass from our core console out to the devices themselves. So you can have tens or hundreds or thousands or tens of thousands of these IoT devices in the cloud can be automatically deployed and managed with one click. And you can also do that with the machine learning resources as well. And really, IoT Greengrass covers these main core use cases, right? We've got local actions and remote control. We've got machine learning interface, so we can automatically deploy those models that we attach to our Lambdas. And put those out on the edge, and then we can extract, aggregate, and load all of the data that we do while running those analytics on the edge. We've got different kinds of enhanced capabilities. We've got ML inference, so we can run SageMaker Neo. In this case, we're using that for a predictive maintenance thing to see if there's some sort of impending failure that might happen on the hardware. You've also got different connectors for kinds of edge devices to external services. You can also push secrets, so secret passwords or keywords. Instead of manually statically storing those on your devices, you can push those to only the ones that need it in real time, and then revoke those if needed. And you can also be running containers, and you can also have a newer feature where we can stream video and data straight out of your edge device back to the IoT cloud. We've got even more components here. We got local messages and triggers. We can take local actions. We've got data and state sync. We can handle security with Device Defender. We've got local resource access, so you can specifically grant Lambdas access that are running in a container to certain resources, so they're isolated and they don't have access to more than they should. And you can also be doing these over-the-air updates, right? So with a click of a button from the IoT console, you can deploy this thing. And if you had a fleet of wire bending machines, you could be deploying to all of them at once with just as much effort as it does to run one of them. Different local messages and triggers is a really powerful feature of the IoT Core system. So every time a MQTT message is generated by a thing or device going through your gateway, you can take some sort of local action or control, which means you can be even doing things offline. You don't necessarily need a cloud connection. In that case, you can be taking action and do something locally, put something into a local database, trigger something, a device locally to sound an alarm or things like that without any connection at all. And then when you do, you can send those messages out to the cloud and take further analytics, store all that information in like a data lake. Again, these local actions can be run with these Lambdas, and you can push them. And one thing that's cool about Lambdas running on Greengrass is you can have ones that are long running versus a Lambda normally runs for a brief moment. You can be doing those in there. And you can write these things in Python, Node.js, C, or Java. And we support, multiple versions of Python 2 and 3 with that as well. We can be doing over-the-air updates. So again, we can do these bulk updates. You can group your devices together into groups. So you can update entire groups at once and not have to fidget with individual devices, which would allow you to manage a large fleet of this, right? You want to be, IoT Core and Greengrass can be doing the heavy lifting for you, and you can focus on your business problems without having to manage all this stuff yourself. One of the most powerful things you can do, and especially on this device here, and I've actually got it live behind me here. You can see I have it running in my lab. This is M90N running in real time behind me, and it's powerful enough with a these higher end Intel processors. It can be running inference locally on the edge through Greengrass. And what we can do is we can run different containers. We can run SageMaker Neo, which will allow you to take a model you may have built in MXNet or PyTorch and combine that into code that would run locally for the processor on this Lenovo device and be able to do edge acceleration that's optimized for it. And you don't have to do anything on your part other than run your model that you made in SageMaker through a compilation process. And then you can deploy that out by attaching it to the Lambda with your Greengrass inference code and automatically in one click deploy that out to your edge devices. We also have Stream Manager. It's a newer thing. So what you can do is you can take streams directly from your edge device and push those up to the cloud. And you can do things like Kinesis streams, IoT analytics, video streams. You can also set kind of policies around priority or how much bandwidth it would use or the state of your connection to maybe your connection's very, very low. You can accommodate for that. And here's a little bit about how Stream Manager works at a more technical level, since we're trying to do a little more technical discussion here is, so we've got a Stream Manager and a Stream Manager client, and Lambdas can write data out to the Stream Manager client and then store maybe that on local storage, and then you can push those straight out into Kinesis streams and go straight into IoT analytics and have a dashboard available of all the data coming out of your manufacturing system. The rules engine is one of the most powerful parts of the IoT Core thing. And basically, anytime an MQTT message that's being sent out from the edge device can be pushed to the cloud, and you can set a rule for any number of actions that you want to happen. You can filter with SQL-based syntax, which is very powerful. You can enrich your message and add things to it. You can republish it on another topic. You can create a data lake by pushing it into our like Redshift or other analytics services or an S3 data lake. We can run Lambdas in the cloud and create a chain of events. We can send messages out. We can do almost anything. The sky's the limit. You can do so many of these things just off of one MQTT message coming through IoT Core. You have the power to do almost anything you want with it. Well, anyway, we've got other things we can do with the IoT Core system. I think we've covered most of them here, but in the gist, really what we need to wrap up is we've got machine learning inference we can be running on the edge. We can do video analytics. We can do video streaming. We can do all the edge compute that you'd like, and we can do all of this on a Lenovo device running the edge. And what's cool about this device here is you can see these big fins behind me. They makes no noise. There's no air going through the unit that could clog it up. There's just these fins that keep it cool on top of it. So it's really kind of a optimal solution for an industrial setting where there may be dust or things that might want to get into it. There's nothing maintenance as far as unclogging things going on there. So these are all the kinds of things that we can route our data through, sort of our manufacturing service bus, if you will. We've got all these different data platforms, and we can do all kinds of analytic services. We've got Elasticsearch, Konstantin showed you. So there's a way through the rules engine IoT Core, he's routing this data coming out of the edge device, and he's pushing it up to Elasticsearch service, and then you got to combine a dashboard, and that's how you're seeing those visualizations happen there. You could also do like, Hadoop and Spark through our EMR stack and get deep analytics based on that. It would be a sort of not real time, but later, doing really, really deep analysis. Kinesis data streams can be pushing this data all around to different services and teeing off, so one thing won't affect the other. And we've got all these different databases to store things in, and we can ingest it with IoT Core, or we can use Glue or DataSync, and then running all these things in the edge. So we have, a bunch of devices like the Lenovo Gateway here that can run on the edge and store things and do things locally with, even if you don't have an internet connection, you can still get a benefit here. Right. So thanks a lot for everyone taking the time to listen. We go into hand it back to Steve here.
Hey, Ryan, quick question. What other things can I do with IoT Rules? And can I do many things at once?
You can. So think of it like a smart router. You can have, by default, I think up to 1,000 rules. So you can run a query, a syntax to filter out a rule, and then take an action. You can have up to 1,000 of those going on at once on your account. So you could be doing an immeasurable amount of things with the same data all at the same time. And if you're doing things via serverless, it could scale fairly indefinitely as much as you'd like.
Hey, Konstantin, how do I deploy to thousands of devices through your system?
That's a really good question. For example, you can use the capabilities of AWS IoT Core to manage the device groups and your device fleet, and just provision the gateways with the necessary keys, and it will work like a charm from there.
Okay, and then in your architecture, how many edge devices are integrated into the solution?
Right now, there are 2 devices. One of them is, and 2 devices, I mean, like in AWS IoT Core. One of them is Greengrass Core installed on the Lenovo Gateway, and the other one is a helper device which collects the data from the sensors and sends it over MQTT. This is considered a thing in AWS IoT Core, and thus we have 2 devices. But we have much more physical devices, but they don't have any shadows in IoT Core.
Mark, from a Lenovo standpoint, you've been putting your boxes into a lot of smart manufacturing. What are you seeing for acceptance of this whole smart automation on the factory floor? What are some of the challenges that you're seeing?
That's a good question, Steve. I think it's a combination of, a lot of the deployments work, but then there's not scale that goes behind it. So I think it's just around being able to answer the questions around the security protocols and obviously getting all the right decision makers in mind to close out that large procurement opportunity.
We haven't talked about connectivity options from a back end standpoint, into the cloud. Mark, you got a lot of different connections in there around IoT, but you're running NB-IoT, you're running CAD-M, you're running all these things that are there. Doesn't really matter to you from that standpoint, does it, from an edge computing box?
No, but obviously we know customer needs are specific. So most recently we just picked up, key carrier certification here in the US. We have LTE support now. And I think it's around future proofing, right? We know customers don't want to standardize on dozens of edge devices, and our products are able to fit in various needs and sizes.
Excellent. Ryan, from an AWS standpoint, what kind of support do you give to the Klika Techs of the world to help them with the migration?
Yeah, so we have a fairly rich partner program called the APN, and so partners can sign up and get connected with other partners and customers through AWS and help them go to market, help them grow their business, get competencies in certain technologies, and show to other people that yes, our individuals are trained and certified and they're doing the right things, that Amazon and AWS set the bar high, they meet those goals, and that you can trust partners like Klika Tech that are going to be competent to do the tasks when you hire them out to build up your IoT solutions.
Constantine, what are some of the biggest challenges you have implementing your solution into clients?
Great question. So the most important thing is to, from the solution architect part of my work, my job is to correctly gather requirements and to bring all the AWS services that will be needed and let's say so to deliver this architecture to our clients so they can understand it and decide how to move further.
Ryan, most of the people that are attending right now are domestic. They're US based, but everybody does business internationally as well. Is there any challenges to running with AWS IoT from an international standpoint versus domestic?
Not really. We have 24 different regions around the world with over 47 availability zones. So we've got several in Europe, in Asia, in APAC, Japan. We've got a lot of regions, and in a region is always comprised of 2 or more availability zones, which is comprised of many data centers. So the scale that we have worldwide is quite large, and in most areas you've got coverage where, say, you're working in like France and data can't leave the country, or you're working in China and the data can't leave the country. We've got availability zones and regions in those areas to run these IoT workloads for you.
Mark, you're all about partners and distribution partners and things like that, basically on your go-to-market strategy. What are you looking for from a partner? I mean, what's that partner got to, where do you see the success level with partners?
Yeah, I think it leads into, we want partners to know what their goals are. Because as we highlighted before, it varies the needs and not everyone's going to do everything. But willing to, obviously highly engage with us, just like we don't want to cold hand off to partners. We have to be able to go hand in hand through the customer journey together. It's not about us selling or us just stacking hardware in for someone like Klika to go bundle. It's really around the partnership with go-to-market, both with messaging and that customer journey.
Excellent. And Konstantin, are you finding that most of your clients are wanting to go to POCs to initially start the journey?
Yeah, I would say so. So first of all, we do propose to create a POC to bring to give our customers understanding of the value of the product and of feasibility of the product. But then we also think about how can we turn these POC products into MVP and other phases which can be used in production by our clients. So it's important to understand from the very beginning how we will evolve our architecture, how we will evolve our embedded system, how we evolve the overall solution to provide all the necessary part from security to safety to reliability to scalability, everything that are critical for correct system functioning.
Excellent. And Ryan, are you seeing POCs also from everybody that's trying to play with AWS in the beginning?
Oh, absolutely. And part of the APN program for partners, we have ways we can help partners either by providing technical resources or assistance financially to help with credits and things like that to run your workload and get it going in AWS. And we're always happy to work with partners such as Lenovo and Klika to help them on their journey there with getting a POC going and identifying an opportunity and making that a successful outcome.
Mark, I know that, as we said, Lenovo is spending a fair amount of time in the vertical market around manufacturing and industrial automation. Are you seeing acceptance by this industry of wanting to do this type of technology creation and putting all these kind of blocks together? Is this what you're seeing out there in the marketplace?
Yes, good question. There's other markets that are probably a little bit more easy to penetrate. But I think with manufacturing, the goal is really not just starting. I know we talked about POCs just a moment ago, but really starting those POCs, trying to understand what the business objectives are, so we can build out strong business cases. Because in that segment, if you can prove out that there's going to be a strong return and it's scalable, not at one site, at various, that's where we're seeing wins.
Mm-hmm. Yes, I would agree. I mean, I guess anything related to COVID selling really well in the IoT space versus some of the other things that are going on, which is crazy. Any other questions that I missed or anything else? Any comments that you guys would like to make to close this thing out? Mark or Ryan or Konstantin?
One thing I wanted to point out, I did recall that you can do 1,000 rules. That's actually a soft limit, so we can actually raise that to even more if you need. If you just need to request a limit increase and provide why you need to do that. We can even go higher than 1,000 things routing rules of your traffic going through. So definitely get with us if your needs are more than that, and we can work on accommodating it.
Excellent.
Thanks.
And I think, Steve, from my side, just I think my contact information is being included here, but if there's any participants that are looking not just to connect with Lenovo or the solution, but with one of our partners, our sales specialist team would love to help the participants out.
Yeah, the same for me. So if you need any help with building IoT solutions, including AWS infrastructure or projects that you might use Lenovo gateways, you can contact me and we will help you.
Excellent. Today has never been a better time to do the IoT projects that we are talking about today. Between the gateways being available, the software, the cloud-based solutions, and the solutions that a company like Klika makes.